Thank you all so much for coming out. I can't really see any of you. There's just a big light, but I assume you're there and you're awesome. So thanks for coming out and hanging out with me for the next 25 minutes. We are going to be talking about MOSE, which is a tool to help you use configuration management servers for post-exploitation. This is the mandatory legal slide that my employers had me put on here. Essentially, any opinions that I express up here are mine and not those of my employer. So I've been playing death metal for several years now. I used to tour, but now I just play local shows every so often. Previously, I've worked as a sysadmin, pen tester, and an SRE. And before I started my current role, I built and ran the corporate red team at Sandia National Labs. And currently, I'm a penetration tester on the product security team at Splunk, which has me finding issues in the various products that we make, teaching secure coding practices to developers, and automating vulnerability regression testing. And I really enjoy automating things. It's one of the pure joys that I have in this world, but I have a special place in my heart for automating post-exploitation tasks. All right, so on the agenda for today, we're going to start by briefly discussing what configuration management tools are. Following that, we'll get into how attackers can take advantage of them. We will then discuss what MOSE is and what we were hoping to accomplish with its creation. And there will be a demo. Also, some awesome dude gave me this like DEF CON New Mexico sticker. I don't know who you are, but this is awesome. Thank you. All right, so configuration management tools. They're used for provisioning systems. So if you have a system that needs to be part of a cluster, or it needs to run certain software or services, you would provision it to do so with configuration management tools. They can also be used to manage the state of systems in your environment. So, for example, if you want to make sure that a service is always running, or you want to make sure that machines are automatically updated on a regular basis, these are some good use cases for configuration management tools. These are some of the more popular options on the market today. We've got Puppet, Chef, Salt, and Ansible. And a ton of companies use a variety of the different CM tools that I showed on the previous slide. So if you haven't run into them yet, trust me, you will. All right, let's talk about what these tools have in common. So they all have this concept of idempotency, meaning that you can run the code as many times as you want and expect to produce the same result. You can also scale infrastructure while guaranteeing consistency across it. And you have the ability to provision machines that are running on a variety of operating systems. So you could have a Puppet module, for example, or a Chef Cookbook or Ansible Playbook that works on Red Hat, SUSE, Debian, Ubuntu, Windows, etc. You get the idea. And they all have a form of secrets management, which we'll get into a little bit later. All right, so a common question that comes up around this technology is, who needs it? We've got containers and Kubernetes, right? And so there's a couple of things to consider here. First and foremost, not everything can be a cloud-native ephemeral workload that runs in a container. And it's typically not a trivial effort to migrate older monoliths to container-based deployments. I mean, hell, sometimes it's not even possible. And you still have to install, configure, and manage your Kubernetes deployment with something. Ideally, something that's repeatable and can be tested regularly in an automated fashion, like configuration management tools. All right, now that we've discussed what these tools can do, let's get back to talking about how we can abuse them. The great thing about successfully compromising a configuration management server is that it gives an attacker the ability to run any command on every managed system. This means that you can do things like introduce backdoors, add, delete, or modify files. You could just collect a bunch of shells. I mean, really, the only limitation is your imagination. And so long as your implanted code isn't changed or removed, most of these tools have a built-in guarantee that your code will run on a regular interval. So persistence is effectively built in for you. And another great feature, these tools all have secrets management solutions. Most of the time, due to the nature of CM tools, these secrets are usable across a number of managed systems. Subsequently, stealing them can provide us with ample lateral and vertical escalation paths. And so, quick story time. A while ago, I was on an engagement and I compromised a Jenkins box through an open Groovy console. Once I had my hands on the Jenkins SSH key, I was able to get into around 15 or so systems. One of them was a Puppet master. And so from this system, I was able to compromise hundreds of servers, countless databases. I got into the devs chat server, which is always entertaining. I got in as admin for their code repo. It was a real good day for me, and not as good of a day for the target. But with this context in mind, let's move on to talking about MOSE and where it fits into all this. So MOSE is an open source tool that I came up with in December of 2018, and I released it and presented on it at DEF CON 27 in August of 2019. So far, we have a small team of core developers, and we're always looking for contributors and testers. So if that's within the realm of possibility for you to assist with, please help us. MOSE is effectively a translator between a user and a variety of CM tools. The idea being that we know what commands we want to run on our targets, but we don't necessarily know how to implement them for a given CM tool. MOSE takes the commands or scripts that you want to run on CM managed systems and translates them into a format that a given CM tool can understand. It's written in Go, aka Golang. I chose Golang because it has a few really useful features. First and foremost, it enables us to easily target a wide variety of operating systems and architectures. It also has native concurrency and allows us to generate a binary that can run on a target system without having to worry too much about dependencies. I was motivated to create MOSE for one main reason. CM tools can be as difficult to exploit as they are powerful. One reason for this is that each CM tool has its own learning curve. If you check out the docs for any one of these tools, you'll quickly see that there is a lot to digest. And there are many tool-specific idiosyncrasies and gotchas that you need to be aware of before using them. They also have significant differences in their workflows, syntax, and architectures. And since you will likely encounter several different CM tools while on engagements or at different jobs, you'll have to deal with this learning curve multiple times over. At the end of the day, you can't choose what tools your target uses, and so you want to be able to weaponize them all without having to worry about tool-specific differences. It's also important to keep in mind with great power comes great responsibility. You can break a ton of systems while attempting to backdoor a CM server if you're not careful. Imagine accidentally taking down hundreds of production servers all at the same time. If that's not in scope for your engagement, which I guarantee it's probably not for any pen tester ever, you'll be in a world of hurt. And if you had to manually do what MOSE automates for you, you'd have to do the following. To start, you'd have to figure out how the CM server is configured. And fair warning, a lot of the implementations of these tools that I've seen lack uniformity in how they do things. Apparently, best practices are merely a suggestion for a lot of organizations. So you'll need to figure out how they've done their deployment before you can get to the good stuff. This typically involves a lot of finding and grepping, and it can get to be time-consuming and torturous. Once you've got the lay of the land, you need to figure out where your backdoored code needs to go. And depending on how the environment is configured, this could be in a number of different places. You could have a configuration management server that is supporting a number of different clients, for example. So if you put your backdoored code in one particular place, it could only hit one client. If you want to hit everyone, you got to account for that. And once you've got your backdoored code into place, you need to figure out the file or files that you need to reference the code in. And this is the tricky part. You make changes to those files in order to hit whatever host you're targeting. So Salt and Ansible, for example, are YAML-based. YAML is white space sensitive. So in a less than ideal scenario, you could put in something that just breaks the YAML. So the CM server breaks, not ideal. Even worse, you have a side effect where you put in valid YAML, but it's not indented where you hoped it would be. So essentially, you end up doing God knows what to whichever systems. So that's really dangerous. You got to be real careful there. So once you go through that, you need to figure out where the secrets are stored and how to decrypt them. And this method, of course, varies for each CM tool. All right, so that sounds pretty painful, right? Fortunately, MOSE is here to help. To start, MOSE automates all the aforementioned steps for you, which is already a massive time saver. In addition, all those awesome post-exploitation tools that we know and love? MOSE makes it really easy to deploy them en masse. And for some of the CM servers, you can strategically pick the nodes that you want to target for specific tasks. So this could be uploading a web shell for all of the managed web servers, or popping a reverse shell on all the managed laptops when they come online. Or you could just introduce a payload specifically targeting managed Windows servers. And so because MOSE allows the user to clearly go from thought to command without having to go deep in the weeds of tool-specific details, it helps to prevent someone less experienced with these technologies from accidentally decimating a whole bunch of systems all at once. Furthermore, it empowers you to focus on what you know and not have to get wrapped up in the minutia of learning new technologies in a limited amount of time in order to achieve your goals. And you don't need to know tool-specific implementation details to run MOSE. Commands are input the same way for all supported CM tools. The code that MOSE uses for payload generation has the same core pieces and directory structure, which makes it clear and straightforward to develop and modify as is needed. So if there are users that do have CM experience, you can use MOSE to customize your attacks further. MOSE relies heavily on templating for CM code generation, so advanced users who have experience attacking CM systems can modify these templates to extend on the functionality that MOSE provides out of the box. All right, so this is the workflow for MOSE. Essentially, again, it's written in Go, so you have to compile it. Once you compile it, you have this MOSE exe. And in this particular instance here, we are planning to run ls on managed Chef agents associated with a Chef workstation or server that we've compromised. And for people that really like to get in there and tweak knobs, we've got a settings.json config file so you don't end up with CLI soup. So essentially, once you specify this command, you would run it. And what will happen is it'll generate a payload for you. It'll generate a binary. And by default, it will stand up a web server that you can use to transfer that binary to your target. Alternatively, you can just say that you want to spit it out to the file system, and you can transfer it however you choose, SCP, whatever. Once you get it in place on your target, you run it, you'll answer a couple questions like, do you want to back up all the important files on the system you're about to modify? Unless you're trying to be super stealthy, like this is probably a good idea, right? So you do that, and you're off to the races. MOSE will introduce your backdoored logic and try to pillage all of the secrets. All right, so we're going to do a demo. And in this scenario, we're going to leverage MOSE against a compromised Chef workstation for both lateral movement and persistence. Compromising a Chef workstation enables us to do things like introduce new cookbooks to the Chef server, which is the mechanism for managing Chef agents. We can also modify the existing cookbooks used by agents connected to the Chef server. And lastly, this is where we can find and decrypt secrets. So needless to say, this is the optimal system to compromise in a Chef environment. It's important to note that we are in the post-exploitation phase of this engagement in the scenario here. So it's assumed we've already done some of our due diligence in terms of recon and have some understanding about the assets that are on the network. All right. Give me one sec. There we go. All right. So to start, we're going to take a look at a payload that we are going to run against one of the targets. This is just a reverse shell through Python, pretty textbook. So essentially, we're going to take this script and we are going to upload it to the Chef server, and then we are going to use it against a Chef agent or several Chef agents, depending. So this is us generating the payload, and then we are on the workstation that we compromised. We download the payload and run it. And when we run it, we see that there's a couple of Chef agents that are associated with the Chef server. Chef workstation, dev system, and web server. We're going to opt to just hit the dev system, so we're going to pop a reverse shell on the dev system. And so essentially, again, the revshell.sh that I showed you earlier, that's now on the run list for the dev system. And it looks like we found a secret, so we'll go ahead and hold on to that for later. That could be good. And so now, typically, Chef agents check in with the Chef server every 20 minutes. I've sped it up here, but basically I set up a listener waiting for the agent to connect back, and automatically it's connected back to me. Again, if you're doing this in real life, it would probably take about 20 minutes. And we're just kind of looking around, seeing some interesting things like this. And we're also going to take a look at the hosts, and it looks like there's a MariaDB system conveniently hooked up with this system, so we can test out that secret that we found earlier. And in case anyone's confused, MariaDB is a fork of MySQL, so that's why I'm using the MySQL executable to connect to it. That worked great. We can come back and pillage that later. We also noticed there was a web server, so we're going to go ahead and target the web server next. And in this case, we're going to upload a web shell, and then we're going to backdoor the www data user with my beautiful sed. So run the payload, and what it's going to do, it's going to generate we're going to run MOSE. It'll generate a payload that we can drop on the compromised chef workstation. When we run it, we can this time say that we want to target specifically the web server. And one thing that's important to keep in mind here is anything that's kind of funky in terms of configurations on the different systems that you compromise, chances are that's going to be the same everywhere because, again, this is a CM managed environment. So, for example, that permit root login, we can assume that's on most of the systems. Here's the web server that we're hitting. And as you can see, there is nothing to see here at the moment. But when the agent checks in with the server, typically in 20 minutes or just immediately because video, we get our web shell into place. And for the sake of this demo, we'll say that this web server is externally facing. So this could be a means for us to get back in if IR pops us and kicks us off of the chef workstation or the dev system that we have a reverse shell to. So indeed, it looks like we're running Nginx and the www data users there. So that was a pretty decent user to backdoor. And we'll just check out our sed work, make sure that we did well with that. It looks like that's in place. Now we've got the www data user. And if we check out the hosts, it looks like this system's connected up with the dev system and the chef workstation. So this could be a good means for us to go again from the outside in. So now we can lay the framework for that. Essentially, maybe using something like SSH. So we'll go ahead and generate a rogue SSH key. And after this command. And again, just to kind of reiterate this, because we saw the permit root login, again, it's a CM managed environment. So that's a setting that's probably in place for all the systems. So again, we can exploit things like that. So here is the SSH key gen, and we'll go ahead and grab the pub key and then get into place. And of course, because we have shells to the dev system and to the chef workstation, we could just knock those in manually. But again, if IR comes in and they remove our key from the authorized keys file, we are kind of SOL. But if we leverage CM, thank you. If we leverage a CM server, then even if they remove it, it'll come back in 20 minutes. And the same thing applies to our web shell and our reverse shell. Now, of course, with the reverse shell, they could just do something like, blacklist our IP. But with the web shell, they remove it. They don't check the CM server, which chances are they won't. Not in my experience anyway. That'll come back. So here we are just getting our payload to throw the SSH keys into place for the chef workstation and the dev system. And when those systems check in with the chef server, then those will both be loaded up in the authorized keys files. So let's look at this from the outside in. Let's pretend that we lost our shells and just got totally kicked off the network. So essentially, we wait for the web shell to come back. We use it to get a reverse shell. So now we've got root on the web server. And because we also have those pub keys that are being kicked into the authorized keys files for us, we can go ahead and just SSH into them without a password, which is great. And if it doesn't work the first time, that probably means that the agent hasn't checked in with the server yet, like here. So you wait a couple minutes, you try again, and everything's probably going to be dandy for you. Like that. Thank you. All right, now let's get back to... All right. So I imagine after that riveting demo, you all want to give this a shot. Fortunately, I've created test labs for all of the CM systems, so you don't have to go through the pain of setting them up. And they're all Docker-based. There's one Vagrant-based one that's one of the Chef ones. Chef does not like to be in containers, but we through some black magic, made it work anyway. So there are some Docker environments for Chef. So please check these out and mess around with the tool. Also, like if you use this in engagement, before launching this against a whole bunch of systems, run it in the test environment. Make sure it works properly how you expect it to. And you can actually do the demo that I just showed previously by using the Chef Test Lab repo. And if you watch the DEF CON version of this talk, you can do those demos through the Puppet Test Lab repo. So we're currently working on supporting all the tools, but we're not quite there yet. MOSE is open source. Please help us get there with your contributions. We'd also love some feedback from testers. Let us know if the tool's working out for you, what we can do better, what we've done great. Salt's almost there. We're not quite there yet, but we're very close. Like to thank a couple of rock stars in my life. Al is the other contributor on the project, and he's done some amazing work. I don't know where you are, but you're wonderful. Thank you. And I'd like to thank my wife for supporting me, working a lot of extra hours outside of work and making this happen. So thank you. And I really like to thank the B-Side staff for making this an awesome event year after year. So thank you guys. This is a real treat. I love this conference so much. So it's cool to be talking here. All right. So the QR code will take you to the Master of Servers project. If you don't trust it, that's fine. There's all the links that you need there. Also, real quick, Splunk is hiring. If you want to be my boss, the ProdSec team is hiring a manager. So if you want to be my boss, there's my contact info. Get with me. We're also looking for senior and principal level product security engineers as well. So if that's of interest to you, there's my contact info. And I don't have time for questions. Maybe I have a time for one question. Thank you. That could be interesting. We'll have to see how my employer feels about that. Good question. All right, cool. Thank you guys so much for checking this out.